Hey there, and welcome back to another Papetti Math YouTube video tutorial, where we're going to be exploring our final lesson in this chapter on exponential functions together. And this brings us to lesson 7, where we're going to compare linear versus exponential models. It says earlier this year you practiced with linear functions and word problems involving linear functions. Recently, you worked with exponential functions and word problems involving exponential functions. Today, you will be combining both of those ideas to make a choice whether it is a linear function or an exponential function that's being represented. So let's just recap on what we've learned about linear and exponential functions in this table provided. Linear functions are in the form of y equals mx plus b, where m is the slope and b is the y-intercept or the initial amount, while exponential functions are in the general form of y equals a times b to the x, where b is the growth or decay factor and a is the starting value, initial amount, or y-intercept. In linear functions, if the problem is growing or decaying by a constant or the same amount, use a linear function. And if the problem is growing or decaying using multiplication words, for example, doubling, tripling, halving, or growing by a percent rate, a constant rate as a percent, use an exponential function. So let's decide in exercise number 1 whether each of the statements provided represent a linear or exponential function. And we're going to circle L for linear or E for exponential. So in part A, it says Bruce has 200 stamps in his collection and collects 20 new stamps each year. So after 1 year, he's going to collect 20 new stamps. After the next year, 20 more new stamps. The next year, 20 more new stamps, and so on. So if he's collecting the same amount of stamps every year, that is a constant amount being added on. So that makes it a linear function, as we just saw in this table above, where it says it's growing by a constant amount, use a linear function. Let's see part B. A person buys a stock that quadruples every 5 years. So a person's buying a stock and it's quadrupling, which means it's multiplying by 4 every year. Multiply by 4, multiply by 4, multiply by 4. And now we've seen exponential functions enough to know that if we're constantly multiplying by the same number over and over, that is indeed an exponential function. In part C, we have a population of a town increases by 7.5% each year. Every year, we're going to add 7.5% on. And let's go back to this table. If it's growing by a percent rate, use an exponential function. So that percent rate that it's growing by is our little hint at saying use an exponential function. In part D, we have the number of pandas decreases by about 50 pandas each year. So every year, we subtract 50 total pandas from the population, minus 50, minus 50, minus 50. And repeated addition or subtraction is a hint at a linear function, because that would be a decaying by a constant amount, the same amount over and over, linear right there. Part E, Julia earns $600 plus $4 commission per item sold at her job each week. So she's going to get $4 for one item, another $4 for another item, another $4, another $4. So each time she sells an item, she's going to gain $4 more. So she's going to add on $4 to the amount she earns each week, each time she sells an item. So if she's always adding on $4, again, repeated addition is going to tell us to use linear. And finally, in part F, it says half as much magnesium-27 remains every 9.45 minutes. So this deals with half-life, which is something you'll get into in chemistry. But for now, we're just looking at the word half, and half means to divide or multiply by 1/2 to get the amount remaining every 9.45 minutes. So since we're multiplying by a half or dividing by 2 over and over and over, that's our key over here, halving right here, taking half as much, and that's going to be our clue for an exponential function. So if this made sense and we were clear on just distinguishing whether it was linear or exponential, please give this video a thumbs up to let me know that I helped you out and you're now ready for exercise number 2. Thank you for watching.